Okay guys, today we are continuing with the use Azure Machine Learning Designer to learn about the Azure Machine Learning exercises and do all the data science solutions on Azure. Okay, so this link I have already opened here. Okay, now to continue with this topic, first we need to create a Azure Machine Learning workspace. Okay, so this is in continuation with our previous two courses or hands-on that we have. Okay, so before starting this one, we have to create learning workspace, and the instructions for that are here. So I'll follow this one first just to make you aware of how to create the machine learning workspace, and then we'll start our third session. Okay, so here I have opened my Azure subscription. I have a free trial subscription for a month. So let me go and create a machine learning workspace. I'll search for machine learning. I'll click on this one. I'll create machine learning workspace. And here it's asking me to create a new resource group. I currently do not have any resource group. So I'll just create one. I'll name it as machine learning resource group. Click OK. So now my resource group name is created. Then I'll name it machine learning workspace. Region I will select Central India, that is nearest to me. I'll select that one. The storage account is already created here, right? I'll give my name specifically, my own name. So machine learning storage. So if there are no spaces or hyphen required, I'll just save it with this one, machine learning storage account. Similarly for keyword, I'll give my own name. So machine learning keyword. I'll just do it like that. Okay, this name is already exists. So what I'll do, ML keyboard. Rather, machine learning keyboard. I hope that's not exist. Keyboard. So that's a new one, unique name. So I'll just save it here. Application insight and container registry, I'll keep it as is, right? That's what it's asking me to do, none and none, right? Now let's create this with all these information. I'll click on create, and it will start creating a deployment plan, and it will try to deploy and open this machine learning services. Now I'll go back to the home page and go to the resource group and wait for my resource group to show up. Here I can see the resource group created. Under that, I will wait to see machine learning studio. I'm just waiting to see all the resource group getting created. I'll pause the video here. Okay, now we can see that deployment has succeeded, and we can see machine learning workspace already created, right? Now within my resource group. Now I'll go to the machine learning workspace and I will open the machine learning studio. Okay, so click on the launch studio icon and it will open the machine learning studio. Now once we are into the machine learning workspace, right, we can see the machine learning studio has these many options available. You can follow up other two videos which I posted on my YouTube channel to go through what each of these options will do. Okay, now coming back to this one. So once our machine learning studio is open, we have to create a compute instance. Okay, so to create a compute instance, we have to go to compute page, right? And then we have to set compute instance, compute cluster, inference, all these things. Out of that, we need to create a compute instance with all these parameters. Okay, so let's go to our machine learning studio. Here we'll go to the compute instances, right? Here we do not have any compute instances, but we can click on this new button to create a compute instance, and here it's asking for different parameters to be set. Now I'll open this tab here, enter unique name, location as my same resource group or workspace, and I have to select the CPU with the standard DS11 data science 11 v2 machine, virtual machine. Okay, so I'll select that one. CPU, I'll change the name to compute, or I'll let it be as the compute name. Then I'll select the CPU. From recommendation, I have been asked to select this one, DS11v2, right, with 6 cores, and this is having 14 GB of RAM, 28 GB of storage, and 2 cores, or dual core. Okay, then I'll go to the advanced setting, right? Here we have to enable none, actually unselected, unselected, and unselected. We do not have to enable SSH or virtual network or assign to any users. Okay, because we are doing hands-on, but we can always assign that VM to another user so that other users can run their machine learning models and everything. Okay, there. So currently we'll keep it unselected. So if I go to here, all these are unselected. Okay, I'll click create to create the compute instance. Okay, this is asking for feedback. Just submit that. Okay, so it's showing as creating status, right? Once it's created, it will show as created and it will be in stopped state. I can click on this and click on the start button to start this compute instance or the VM. Okay, so I'll pause the video for now. Let this VM to be created, provisioned, and ready for running our machine learning codes. Okay, so now you can see our compute instance is running. Okay, now according to this instruction, right here for the third module, we have to create and configure compute resources. Okay, so we have to go to Azure Machine Learning Designer. You require compute on which to run the model training system, right? I have already created a compute instance, right? And it's already running. Okay, so you can use this compute instance to test your trained model. That's what we are going to do. Okay, now while the compute instances is starting, or switch to compute clusters tab. Okay, you don't already have the existing compute cluster, so we now need to create a compute cluster. Okay, with all these parameters. First we created compute instances, or instance, right, and which is already running here. Now we are going to create compute cluster. So how we will go to create that? We'll go to the compute cluster tab. Here we'll click on the new button to create a compute cluster, and here you see the location is automatically selected as per my current region, of which I have kept for resource group as well as for compute resources, right? Now virtual machine tier should be dedicated or low priority, so it's a dedicated one, right? CPU with this virtual machine, right? So this is CPU and this is the same virtual machine that I had selected earlier for compute resource, right? Now compute name, enter a unique compute name. It's asking me to provide a unique compute name. Here I'll provide the unique compute name in advanced settings. Okay, and this should be a compute cluster. Well, write the compute ML compute cluster. Okay, now we have to select the minimum number of nodes 0 and maximum number of nodes 2. These are the nodes which will be used to process our data or run a machine learning model. Okay, so 0 to maximum 2, right? And then idle seconds before the scale down, that is when my compute resources are not being used, right? So these number of nodes will reduce from 2 to 1 to 0 if they are not in use. That's 2 minutes or 120 seconds. Okay, here. Now enable SSH and advanced settings. So all these things are need to be unselected. I've kept it unselected, and then we will click on create. So this is going to create a compute cluster. Okay, now it's showing as a creating, right? But after some time you'll see that compute cluster will be started here. Okay, I'll pause the video for now. Once this is created, then we will continue. Okay, now the cluster resource is created. We can click on this one to see it's allocated with this cluster name, compute type, which is under my subscription and or resource group within this workspace, within this region, right? OS type is Linux. This is my VM's sizes, right? Specifications. Now here you can see nodes and the run history. Okay, going back, this is the same sidebar. You can keep it minimized. Now next is in Azure Machine Learning Studio, view the dataset page, right? Dataset represents specific data files or tables that you plan to work with Azure. So under the dataset page, we can upload our own data, or we can work with any data which is hosted in Azure or on-premise data or databases as well. Okay, so let's go back to dataset page. Here it's asking to, there are no data set we have added, right? So we are going to create a data set and from a local file. Okay, so now dataset name, what kind of data type dataset has, and the description about what kind of data it contains, or some small description we have to put. Okay, now we have to download that data from this URL. Okay, so if you copy this and open it in a browser, you'll be redirected to this page where we have this diabetes dataset, which is in comma separated value .csv format. Okay, this is the heading columns, and these are all the data set recorded for each patient. Okay, diabetic patient, along with their status, whether they are diabetic or not diabetic, 0 or 1s. Okay, more about that later. Let's move on to uploading that data set. So name of the data set would be diabetes data set. So I'll just get that name. Data set type is tabular, and the description is that this is the diabetes data set. Okay, put that there and click next. Now where to put that data? Under the same workspace blob storage, under this storage account that we created. Okay, we'll select that as is, we'll keep that as is. Now upload files, right? So we will upload file. So I have saved that data under projects, Azure ML, and here I'll select and upload that data. Okay, now I have to define what kind of file format is that. Okay, these are delimited with comma value. Encoding is Unicode 8, and the data has headers, right? First line is representing the header. So, and skip no rows, so none. Okay, so that I'm going to set here. Under settings and preview, this is delimited with comma separated value, right? And then only first file has header. All files have same header, only first file has headers. That's delimited comma UTF-8, right? All this is set. Skip rows none, and use headers from first line. So this is how the data will look like once it will imported in this tabular form, right? With all the column names, types, right? Click next. Now schema we have to define. Include all columns other than path. Okay, so other than path, all the columns are included in the schema text. Okay, next, diabetes dataset. So this is giving a summary of my data store or a data set. Okay, so diabetes dataset, which is a tabular dataset, right? And the file type is a delimited file type or comma separated value, right? With Unicode encoding, and only first line is header, and this is stored under this data store with this file name, and the path to access that file is this one. Okay, if you want to access that blob store, file store. Okay, so click create, and we do not want to profile the dataset after creation, so I haven't selected that option. Okay, now this dataset has been created successfully, and view the explore page to see the sample data out of it. So explore, click on this data set, go to explore, and here you will be able to see the data set, right? Number of columns 10, number of rows 50 out of 10,000 records. Okay, so here you can visualize that data in the form of table. Next we have to create a designer profile under the designer page. Okay, so we have Azure Machine Learning Designer. That's what the hands-on is all about, right? Azure Machine Learning Designer. So now we are going to create a design. Now in the Azure Machine Learning Studio, you have to go to designer page and pipeline created on date to visual diabetes training. Okay, so I'll go to the machine learning studio and I'll go to the designer, the designer page. Pipeline wrap, pipeline runs. Okay, so once the designer page is open, we have to create a new pipeline and then name that pipeline as a visual diabetes training pipeline. Okay, so here click on this new pipeline button. Okay, now this pipeline has been created. Here you see the name automatically created. We have to rename it as a visual diabetes training pipeline. It will save that name automatically. Now we need to specify a compute target, right, on which we will run our machine learning pipeline. Okay, in the settings pane, click select compute target and select your computer cluster. So here in the settings pane, here is asking me to select a compute instance or compute cluster or attach compute, right? What we have to do is select a compute target, select your compute cluster. So this is the compute cluster which I created, right? So I'll select that one. Next, on the left side of the designer dataset section, we have to expand and select the diabetes dataset that we created earlier from a file, local file that we uploaded, right? So we'll select that dataset. We'll save this compute cluster that we selected and close this one. Then from dataset, this is the diabetes dataset, right? What it is asking, select the diabetes dataset module on the canvas and select and preview the data. So from this dataset, we'll select it onto the canvas, right click on it and we'll preview the data. So we can see the data, right, from that diabetes dataset. Next, in the data set output pane, select the profile tab. Here we have profile tab. We can expand this one and we can see the patient IDs, pregnancies, all this detailed information. Okay, this is just profiling the data. Now review the schema of the data, noting that you can see the distribution of various columns as the histogram. Then close the visualization. Okay, so here you can see all these histograms or bar chart, right? Now let's close this. Next, add a transformation. Now the data has been put into the canvas. Now we have to do a data transformation. So we have to go to the data transformation section in the machine learning designer. This is nothing but our designer will be creating a flow kind of a diagram here on this canvas, Azure Machine Learning Designer canvas. Now here is the data transformation. Okay, you can also use this search button to search a specific action to put it into the canvas. Okay, so within the data transformation, it is asking me to drag normalized data module after the dataset, diabetes dataset, and then connect. Okay, so you can search here by scrolling. Okay, normalized data, or I can also search here normalized data, so it will automatically show up here. Now I'll just drag and drop to connect these. Now within the data normalization, what we have to do, within that normalize settings, it requires you to specify transformation method and the columns to be transformed, and leaving the transformation as T-score. Edit the columns to include the following column names. So we have to include these column names. Okay, copy that. Here transformation method is G-score. Columns to transform. Click on edit column and include column name. So we have to plasma glucose, diastolic blood pressure, triceps thickness, serum insulin, BMI, and diabetes pedigree. Plasma glucose, sorry, this one, tricep thickness, BMI, and then diabetes pedigree. 1, 2, 3, 4, 5, 6. Total 6 columns. 3 and 3, 6. Yeah. We are normalizing the numeric columns. Put them on the same scale and avoid columns with large values dominating the model training. This is what the normalization is called, right? You would normally apply a whole bunch of pre-processing transformation like this to prepare your data for training. Here we are only normalizing the columns so that it will not tuple our scale. So we are putting all the columns on a same scale. Okay. Now we are ready to split the data into separate data set for training and validation. So that's where our training and validation part comes after normalizing our columns or data. So I'll save this one. Now within the data transformation, we have split data module, right? Earlier for data transformation, we used normalized data module under the data transformation section. Now we have to use split data. Okay, so under the same section, I'll search for split data. That I will put here on the canvas, and then needed to split data into separate data set, right? In the pan on the left, okay, data transformation section, drag split module onto the canvas. That we have already done. Under the normalized data module we have done, right? Then connect the transformed data set left output of normalized data module to the input of the split data module. So left part of this normalized data module will be attached to the split data module. So this is left, this is right. The left one will be moved attached with the split data module. Now, split data module, under that we have to do all these settings. Split rows, done. Fraction of rows in the first. So 70-30, that's what we keep, right, for training and validation of our data set. Now, so we'll keep it for 0.07. That is 70% of the data will be used for training and 30% for validation. Random seed, sorry. So that would be 1, 2, 3, and then stratified split is false. True random seed is 1, 2, 3. This is false. Add model training modules. Okay. So now we have to add our training models. Okay. So for this kind of data set, we are trying to predict whether a patient is diabetic or not diabetic, either 0 or 1, right? So that is a kind of regression problem, right? And here we have to find out two values, either 0 or 1, within two classes. Either patient is diabetic or patient is non-diabetic, right? So according to that, we have two class logistic regression. Okay, we have to use this module on the data set that we created for training, right? 70% of the data set. So let's move to our canvas and go to model training module section. So I'll click here to clear that. Now model training section is here, right? Under that we have train model. Select that one, drag here. So I selected train model. And modify setting to set the label column to diabetic. So which column we want to predict, that's we are going to select. Okay. So first of all, output of the split data module, right? Connect the left side of the output of the split data module to the dataset right input. Okay. So this is left one. It will be connected to the right side of the train model. Okay. Okay. Now, once the splitted data is set here, now we have to define which model we are going to run, right? Two class regression. So that we are going to select two class regression. Two class logistic regression. We'll put it here. Just a minute. I'll just drag it here and put it here. Now this will be attached here. Now train model is showing some kind of error. Why? Because to train this model on the data, we have to select which, after training, which column need to be predicted, and we'll do that from here. Once we have selected the train model, we'll click on edit column, and the column that we want to predict is diabetic, whether that patient is diabetic or not. Okay, so that's there. Now close this one for more readability. Now, once we have selected our regression algorithm, right, on which we have to train our splitted data model. Now the output of this trained model need to be checked whether how the model is performing, right? So we'll score the model. That is basically doing the evaluation and scoring of the model to identify with how the model is performing. Okay, trained model is performing, whether it's accurate, and the accuracy of the model to predict a diabetic patient, right, out of the given data. So to test the trained model, we need to use it to score the validation data set we held back when we split the devotional data. So the 30% data will be used for validation. 70% we have splitted and sent it for training. Now the 30% of the data from this selected data will be used for model validation. So to do that, we have to expand scoring and evaluation section, right? And drag a score model. I will not go to this section. I will just search for score model. Here I selected here score model. Now, once the score model is selected, result dataset to write output of the split data model to the dataset write. Okay, that is nothing but once the score model is selected, you have to select and attach trained model to the score model, and the 30% data which is used for validation of the model we'll put here, and then we'll put an evaluate model section or module here to evaluate the model performance. So here, let's do that. I'll just drag it below here, scroll down. So this is going to be attached to the score model after my model is trained, and then 30% of the data will be used to validate and score that model. So this is it. Then we have to do the evaluation of the model. So we'll select evaluate model, and I'll just put it here and click on evaluate model. So this is all about designing from dataset, then first importing, uploading the dataset, then normalizing the dataset columns so that it will not be biased or any error in the dataset we need to remove, right? Clean up of dataset, then splitting the dataset in to train and validate our model. So 70% of the data we are using to train the model, and to train the model we have selected this two-class logistic regression algorithm. This algorithm is going to change as per the scenario, whether we are doing a regression or classification, right, or prediction, right? So those kind of algorithms will select according to our problem statement. Now, once the model is trained, we will be scoring and evaluating the model. So we are using 30% of the data that we have splitted out of 100% to validate the model and then evaluate how the model is performing. Now at the top right, click submit. So our model is, and this flow design is complete. So I'll just click on submit, and this is asking me to name this experiment, because all this flow design that we have created will be considered as an experiment. Okay, so I'll just name it as Machine Learning Designer Train Diabetes. Okay, this is the experiment name, and then I'll submit it. once that is done, run it and initialize the computer cluster and then run the pipeline, which may take 10 minutes or longer. You can see the status of the pipeline up to the top right design of the canvas. Okay, now this is a new one, so I will this as create new and then this name and then submit. So this is going to take 10 minutes of the time for running the pipeline. Okay, it is running, right? We can click on view run overview to see the status, right? We have submitted at this time, duration, everything is showing here. We'll wait when this model is completed. Pipeline parameters that we set, all those things will be shown here. So I'll pause the video for now. Before that, you can see each steps being shown here, right, in the processing part. So once the experiment completes, this flow completes, we'll be able to see green tick marks if everything goes wrong. Okay, and if something goes wrong, we'll see the red marks. Okay, so let's wait for it to complete. Okay guys, now you can see each of these steps has been passed and showing as a green, right? Now if you right click on this and just preview the transform dataset, right, you'll be able to see different fields, their histograms and everything in this section. So that's about the normalized dataset. Here if you want to see the dataset 1, which is 70% of the data, right, 70,000, right, and then dataset 2, which is 30% of the dataset of 30 or 3,000 records. Okay, trained model. So here you'll see the model name and the details. I don't know why it's not showing. Anyway, now is core models, core data set. So here we see the scored probabilities, right, for each of the records. For 3,000 records on which we have validated our model. Here 90% or 91% chances that this patient is diabetic with 1, right? Here almost 0.0%. So based on this, it is evaluating. It's more, if it's the data of the value, the probability is more than 5.5, that means that patient is diabetic. It's less than 0.5, so non-diabetic, but it's more than 0.5, so diabetic, more than 0.5, so it's diabetic, more than 0.5, it's up, it's near to 0.9, right? So it's high probability that this patient is diabetic. Now model evaluation. So here the evaluation result we can see, right, 0.5 means more diabetic, and this is precision curve, left curve, we can search, we will search around that, and this is the ratio score mean on which values are predicted. Now this is confusion metric where actually predicted and actually diabetic are this much, actually not predicted, sorry, non diabetic and correct prediction style. There is concept called true positive and false positive, right? So, and true negative and false negative. So this confusion matrix gives the details about how many patients fall under those categories. Okay. Now, this is what all this section is asking us to check. Within the flow itself, we can be able to see trend model, scores, evaluation model and scores, and we can compare side by side. Okay, so that's it about for today. We'll continue from next day in the next video. Thank you for watching. Bye bye. Okay guys, now we are back to our hands-on for machine learning. Okay, and we are continuing with our third hands-on. Use Azure Machine Learning Designer. This link I have opened here in this new tab, and we have completed in our last video till this one, where we created our machine learning pipeline. We also call it as an experiment, and then we trained our model on diabetes dataset after normalizing that data and then splitting it into 30-70 ratio, and then running a two-class logistic regression to predict whether a user is diabetic or non-diabetic, and then also scoring and evaluating the model, how it is performing on our training data, validation data, right? So this we have completed. Now we are moving on to create a interface pipeline, inference pipeline, sorry, my mistake. Inference pipeline where inference pipeline is used to train model to predict labels for new data, right? So whatever the model that we trained earlier, right, we evaluated on our validation data. Similarly, we will use that trained model now to predict new data or new patient data, based on which we'll predict whether that patient is diabetic or non-diabetic. So let's create this inference pipeline. So I have opened my machine learning studio. If you want to learn it, first you go to your machine learning workspace and then launch the machine learning studio. You will be redirected here. Now to create the inference pipeline, we will go back to the pipeline that we created earlier. We'll open it, and this will open our designer, and this is the flow that we created and also trained our model, right? Now here you see the option, right, create inference pipeline. We'll click on the real-time inference pipeline. Okay, here it got created with this name, right? Now we will name it as a predict diabetes. That's our inference pipeline. Here you can see real-time inference pipeline. This inference pipeline is saved now. what it actually does. Okay, this inference pipeline is used to expose your trained model as a service, so that when you send patient's new record, based on these new records, that service will run your trained model and try to predict your patient is diabetic or non-diabetic in this case, right? So now note that the inference pipeline assumes that the new data will match with the schema of the original diabetes dataset from the training pipeline included. However, this input data includes diabetic label that unintended to include in a new patient data for which a data prediction has not yet been made. Delete the diabetes dataset. Now this dataset is not required anymore, right? Because now our model would be expecting a new data, not a dataset, okay, for patient, and then it will try to predict based on the trained model. So here we have to use enter data manually module instead of diabetes dataset. Okay, so we'll remove this diabetes dataset, and here we will put enter data manually, and we'll put it here. Here it's asking for some data which we can put manually. So let's copy this data, right? And then enter data manually. This is given here, CSV input. So copy this one and just paste it here. You can click allow, so it will try to paste that data here with headers, and that's it. So you have to mention as header true and the data is comma separated value. That's it. Now close this one. This data is already provided, then add it. You want to see the data again, click on here and you can see this one again. Now moving on, the interface pipeline includes the evaluate model. Now we are not evaluating the model, right? We have already evaluated the model, is showing well and good for the scenarios. So now the evaluate model will also be removed. Okay, so we are deleting that. Output for the score module includes all of the output features as well as score probability score, and limit the output to only prediction and probability. Delete the connection between score module and the web service output. Okay, so first of all we need to delete evaluate model. This is not required anymore, right? And here score model is connected to web service output, right? So score model and the web service output, this connection needs to be removed, and we need to add an execute Python script model. So let's copy this one and search for this module. Execute Python script, and then I have put it here. Let's keep it ready. Here you see this is a Python code we need to write to run the Python script, and so for now let it be as is. What next? Python language section, connect the output from the score module to the dataset 1 leftmost input. Okay, so this is dataset 1, so this will be connected back to, sorry, you can remove this one by clicking on this. Once it's highlighted in blue, you can delete. Then this will be connected to execute Python script. Next, and connect the output of the execute Python module to the web service. Output, you hover over this, this is giving result dataset 2. So web service output data frame directory, image directory. I think like this. You have to add. Next, so connect the output of the execute Python model to the web service output. Then modify the settings of the execute Python script. So now we have to modify the script. Our default script has been generated, right? When we added execute Python script. So now we'll modify with this new one, which is given here. So I'll go into the execute Python script, click this one, and just replace everything with the code given there. Okay, so I copy paste it. Now if you see here what it is doing, it's importing a pandas library, then it's defining Azure ML main method in Python, right? Now data frame could be none, data frame 2 could be none. So it's taking two parameters, both of them are initialized as none. Then data frame 1 is all this patient ID, score labels, score probabilities, and then rename columns equal to score label as this one and score probability as probability. So here we are renaming these two columns, score labels to diabetes prediction and score probabilities to probability, in place equal to true. So only these field names will be changed, and then it will return the scored results, right? Now after pasting the code in the module, verify that the code blocks look similar. So here they have put given a screenshot of what the design will look like. So here enter data manually, we changed, we removed evaluation model and put our execute Python script, and in the Python script we added this code to run our model or execute the Python script based on the new data that we entered. And all these things you see, diabetes training, normalized data, diabetes train model. So these are the data set will be used to train the model again, and then run or apply the transformation. Will transform this normalized data, right? And then score the model based on the new data. Okay. So submit the pipeline to the new experiment named this. So we have to say this name, the experiment, and then we'll submit. So this is how our design looks like. I can minimize all these things and click on 1:1. It gives me a holistic view of the flow. Okay, just click outside, so it will all be shown like this. Now that our flow is complete, let's submit that as an experiment. So to submit the pipeline as a new experiment, we have to name it as this. Click on submit, and I'll click on create new because we are going to submit as a new experiment. And then submit, right? So this is serving as a web service input, and this is serving as a web service output. Now this experiment is being run. Once this is completed, we have to deploy the inference pipeline as a web service. Okay, so in the meanwhile that experiment is running, we'll move on to this one. Now you have an inference pipeline for real-time inferencing, which you can deploy as a web service for client application to you, right? So now we will expose that as a web service to run inferencing, to do the inferencing on a real-time data, okay, of the patient. Now if the patient have the inference pipeline not yet finished running, awaits completion, then visualize the result data set output of the execute Python script module to see the predicted levels of probabilities for 3 patient observation input data. So once the flow completes, we have to see how this execute Python script has performed the prediction on the given manual data set for the 3 patients that we added here, right? Whether each of these patients are diabetic or non-diabetic. Now at the top right, click deploy and deploy a new real-time endpoint using the following settings. So first let it complete. Currently it's still in the enter data manually step. Once it's complete, we'll continue from there. I'll pause the video for now. Here you can see now the enter data manually is running, right? Then it will proceed to other next step. So we'll pause it here, okay, and we'll continue once this flow is complete. Okay, here we can see the flow is completed. That will also show up in the notification. This experiment is completed. Okay, so now we have to see the observation of this script. If you click and preview the data, right, result data, so here you can see patient ID and diabetic prediction. So all the patients are diabetic based on this experiment. You see the probability is more than 0.5. Chances are patients are diabetic. So the prediction for each of these patients are 111, right? Result data set 2. What columns? Okay, there's nothing in there. Fine. So this is about the running your trained model on a new data. Okay. Now moving on to the next step, we can deploy this service or this model as a service, as a real-time endpoint. Okay, where someone can give the new data or input the new data and get the prediction in real time. Okay, how you can do that? We can deploy by going to this flow. Here you see the deploy button, click on deploy. Now new real-time endpoint, right? So we'll put all these names because we are deploying it as a new real-time endpoint. Name would be designer, predict diabetes. Description is predict diabetes. And then Azure container instance where we have to run. Now this Azure container instance, if you see here, there are two options: Azure container instance and Azure Kubernetes services. Azure container instance is for development and testing. But if you want a more mission critical service where you don't want your model to fail and be available to service the new data, right? Mostly in production environments, so you need to select Azure Kubernetes service. Okay, so currently I will select Azure container instance, so it will run under container instance. All these things, memory reserve, capacity, enable SSL, all these things, we'll keep it as default and then wait for the service to be deployed. Okay, so I just deployed. So currently it's deploying the model, creating real-time endpoint for model, preparing to deploy, waiting real-time endpoint creation. Okay, so all these steps you can see here. Stream. Deployment in progress for this endpoint. I'll pause the video. Once it's complete, we'll continue from there. Okay, now we see that our deployment is complete, and then we have this designer predict diabetes model. deployed as a service with this service ID, description, it's running healthy, right? And then these are the endpoints through which we can consume or call our service. Okay, now let's go to the consume tab, which gives us an endpoint which could be exposed uh, to call this service or model to run our prediction. And it always works with authentication, where we have the primary key and secondary key. We can always generate a new key to keep this. For security purpose, we can always generate new key to recycle, right? And these are the scripts written to call the service. Here you see I'm opening Python script. So within that we have this URL which is being called and this API key. Based on this URL and API key and the input data of a patient, we can predict and get the results about the patient is diabetic or not. Okay, so what I will do next, on the endpoint page we have opened this designer diabetic endpoint, and we can see in the consume page the REST API and primary key, REST API endpoint and the primary key values, right? Now in our previous sessions, if you have gone through, we have downloaded some notebooks, right? Which I have opened in this tab. So this is for each of the hands-on that we are doing. So I've cloned this from GitHub, right? All these experiments that we are running. Now, get designer prediction notebook. I have to open this get designer prediction notebook, which is this one. Let me click this. My compute resource is running, then only I will be able to see all these things. Okay, so here you see it's asking for endpoint and then authentication key or API key, and this is the patient data on which we are going to run our prediction. Okay, so call our prediction service basically using the endpoint and the key. So I'll copy this endpoint and key from this consume tab of the endpoints. Okay, so first I'll copy the URL, place it here, then here I'll copy the primary key and paste it here. So that's my key. Now once these values are updated, I can run this script. Okay, so you have the run button here, run cell, and you run it, and here you'll see for this patient prediction is 1. That means patient is diabetic because the probability score is 0.7. That means 70% chances that this patient is diabetic, which is more than 50%, so it's set as 1. So that's how the prediction will work. Next, after we are done with exposing our model as a service and then also testing that service using the primary key and the endpoint, we consume that service and run a prediction on a single patient data, right here in this notebook. Now since our work is done here till now, to stop, we can stop this endpoint and also delete any compute instances or resources so that it will not incur any extra charges for running those resources within the Azure. So that's the cleanup stop. You can go ahead and delete this. Designer predicting diabetes endpoint and as well as compute instances. We can stop this. I'll just go here. This is my compute instance. I can stop this. And also I can go here, right, in endpoints, and I can delete this endpoint so that it will not incur any extra charge. So thank you for watching. We'll continue from fourth session in our next video. Thank you all. Bye bye.